Okay, so that's the first thing we're going to use our laws of logs for today, and we're going to use laws of logs now to solve log equations. So these steps you might find helpful, so go ahead and write down. And you might want to notice there's a little note at the very bottom. If you can't see it, it says solving may involve quadratic formula. So if we get a quadratic equation, you may have to use a quadratic formula. So I'll leave this up here for a few minutes for you guys to copy. Okay, so these are the steps we're going to use to solve some log equations. Now basically they're going to come in two flavors. One's with log on both sides of the equal signs, and one where there's a log only on one side. And so that's kind of what happens in step 2. We kind of have a decision to make and a direction to take at that point. So here we go. Now go ahead and write down number 1, please. Now really I would say the only difference in these problems from what we've been doing on, I think it was lesson 8.2, the only difference would be that in lesson 8.2 when we were solving those equations with logs, they had only one log. But in these they're going to have more than one. So we're going to learn how to deal with that at this point. Okay, so you guys wrote down the steps. What do the steps say? That's right. Use the laws of logs to express each side. So I've got a left side and a right side as a single logarithm. So let's look at the left side. Is there a single log over there, or is there more than one? Okay, so we have to use this law of logs to fix that. So what's happening to these two logs? They're being added. So what do you think I'm going to turn that into to make it one log? You're going to turn it into multiplication. So you're going to take your two logs and you're going to multiply those numbers that you're taking the log of. So you have log of x there, log of x minus 3. We're going to multiply those two pieces together. So what we have then would be I'll go ahead and show my work here. You don't have to do this step if you don't want to. But I'm showing this so you guys can see that we need to distribute it, because when we multiply a binomial times a monomial, you need to distribute. So x times x is x squared. X times 3 is 3x. So that's the first thing. And notice, how about on the right side? Do I have only one thing over there? That's good. So we can leave the 3 alone. But you don't want 2 or more logs on one side. We don't have any logs on the other side. But that's what the next step is for. So what does the next step say that you guys wrote down?
Step 2, are there logs on both sides?
So it depends. What we're going to do now depends on what we're looking at. The question is, are there logs on both sides of the equal sign? No. Since that's not the case, then what we want to do is get rid of that log. That's what's making this kind of a nasty looking problem. So there's two ways to do it. If there's not a log on both sides, the way to do it is to do what? What does your step say? Change it to exponential form. So you're going to do your whole left, right, middle thing. Here's your left. Here's your right. Here's your middle. So left, right, middle. Now my log's gone. I changed it to exponential form instead. Okay, so that's how you're going to drop the log when there's only one log in there. All right, so now we're going to go ahead and continue. What do you guys think we're going to do?
Now we got to solve.
We do have to solve. What do you think the first thing I would do would be? Yeah, 3 to the third power is 27, right? Now let me ask you guys this really quick. What kind of an equation is this? Is this a linear equation or a quadratic equation? Quadratic, and how do we solve quadratic equations? Yeah, the quadratic formula. And before we can do that, we need it in standard form. So what do I need to do to get it in standard form? Yeah, we need it ax squared plus bx plus c. So I need to get the 27 on the other side so that this whole thing equals 0. So there's that. I have 0 then is equal to x squared minus 3x minus 27. And now we're ready for the quadratic formula. So I need a new area to write with here. So what we have is 0 is equal to x squared minus 3x minus 27. And we're going to use the old quadratic formula in case you forgot what it is. I'll put it up here for you. All right, so I like to start with blanks. So what is B?
B is negative 3.
What is A?
1.
The number in front of x squared is 1. That's A. And then the last number? Negative 27. And then from here we just got a little bit of math to do. So we have double negatives in the front here, which become positive 3. We have negative 3 squared, which is 9, minus 4 times negative 27. I think it's negative 108. And once again, we have a double negatives there become positive over 2 times 1 is 2. All right. Then we have to do 9 plus 108, which is going to give us 117. And you'd think that that was a prime number, so we're done, but we're not. We do need to break down that square root. That square root can be simplified. Does anybody know what might go into 117? 3 does. How do you know 3 goes in there? Yeah. If you add together all the numbers in a number, 1 plus 1 plus 7, what do you get? And can 9 be divided by 3? Then so can that. That's a little divisibility trick. So, and it works for 9 and 3, but in this case we're just looking at 3. So I guess we could do 9 if you wanted to. All right, but anyway, here we go. 117. It can be broken down into 3 times something. Well, let's see what that something is. 3 goes into 11 3 times. With 2 left over, it makes 27, which is 9. And does anything go into 39? 3 again, right? 3 and 13. And so if I were to break down 117, what can I take out? I can take a 3 out. There we go. So the final answer here would be 3 plus or minus 3 radical 13 over 2. Now really there is one more thing that you should check for. It's not going to apply here, but you look at the 3 numbers outside the root, the 3, and the 2, and see if you can reduce anything out. Can we reduce anything out? Then we're done. Okay? But that's about it. Number 2. Okay, so let's go ahead and do this. Step 1 from your guys' directions says what? Use the law of logs to make sure that we have 1 log on the left side of the equal and the right side. How about on the left side? How many logs do I have? 1. How about on the right side? 2. So we got to fix that one up. So what do you think we're going to do to condense this down? Not quite. Got to think about what we did last time. So here's what we're going to do. We have our 2 in the front. That becomes a exponent. So it's going to be 3 to the 2nd power, right? Which is 9. So that's the first thing you want to do. So that's going to be log base A of 9. Now since I did the power rule, we're going to, and this is, I think some of you guys said this part. Now we're going to change the addition into what? Multiplying. So it's going to be log base A of x equals log base A of what? 45. Now what does step 2 say? After you've condensed it down to 1 log on both sides, which I now have, what does it say? That's right. The question is there a log on both sides? Okay, and what does it say to do when there's a log on both sides? It's like an equation, right? And when you have an equation, if you have the same thing on both sides, you can pretty much just ignore that piece. So we're going to just ignore the logs, and we see that x has to be what? There you go. So sometimes they're super quick like that one. Sometimes they're super long like the last one. Moving on. Number 3. Go ahead and write down number 3. Okay, so I'm going to ask you guys kind of a trick question here. You ready? The first step is decide, is there one log on both sides? Let's take a look at the left side. How many logs do you see? See one log, right? Is there one log on the right side? The answer is no. Why? It's 2/3 of a log. It's not even a whole log, right? So we got to fix that. That's not okay. How do I fix that 2/3? What is that 2/3 going to become? That's an exponent. So it's going to go up to the front here, which is going to give us the following. It's going to become log base b of 64 to the 2/3 power. Now what do you guys think I'm going to do? We got to change the 64 to the 2/3 into radical form so we can hopefully simplify that mess. So let's go ahead and do that really quick. I'll do that on the side. If I change that to radical form, the number's going to go here, here, and out here. So, which one's going right here? The 3 is our root. And here? 64. And out here? Alright, so, question is then, what's the third root of 64? It is 4. Very good. Don't worry if you're not that fast. Take your time. Just break it down with a tree chart like we have been. But if you know it, great. And what is 4 squared? 16. So then here's what I have left. Instead of log base b of 64 to the 2/3, we're going to have log base b of what? 16. Now, next question. Do I have a log on both sides? I do. So on this case, I can just ignore the log like on the last problem. It's not quite as easy as the last problem, though, because there's still a few things we have to do to get x by itself. Now, here's what I have left. X squared plus 8 equals 16. All right. Now, that's a quadratic equation, right? So, could we use a quadratic formula? Yes. But here's the good news. When it's, I don't know if you guys remember that, but when there's no b term in there, that's like vertex form. You guys remember that? So, we can just solve it by getting the x by itself. You don't have to use quadratic formula. Let me show you what I mean. First of all, we're going to move the 8 to the other side. And now what? Just square root both sides. Leaves us with x equals, and don't forget the plus and minus, square root of 8. And yes, we do need to break down our square root of 8. And I think many of us have probably memorized that by now. We've done it so many times. What's the square root of 8? 2 radical 2. And if you haven't memorized it, don't worry. Just break it down like we did when we did square roots. So there you go. First one was pretty tough, a lot of work. Second one was real fast. Last one was kind of in the middle. But just kind of showing you guys all the different things that could happen. You might have those fraction exponents to deal with. You might have to use a quadratic formula. Sometimes it's super easy, just getting the x by itself. But the point is, one log on both sides, at most. And then get rid of the logs by either crossing it off or changing it to exponent form and then going from there. Okay? So, all right, so let me have you guys try a few. So there's 2 problems for you. One of each type. One that has logs on both sides and one that has log on one side. Go for it. Okay, guys, I'm going to go and put the answers up here. For the first one, you should be getting x equals 28. For the second one, you should be getting x equals 3 plus or minus the square root of 73 over 2.